everyone, here's another example from the modeling stuff. So we are trying to write a formula that models some real world situation, or moderately real world. This is a fairly mathy situation in this one. So here we have a rectangle and it's sitting in the XY plane so that its right hand side is sitting at x equals 9. So x equals 9, when you see that, you want to think not only about this x coordinate, but x equals 9 is actually the equation. So if we're in the xy plane, it's the equation of a vertical line. So we have one side sitting along this vertical line. And then its top left-hand corner is just touching the curve y equals the square root of x, which looks something like half of a sideways parabola. If you don't already know what this one looks like, we'll be getting to them very shortly, but you can absolutely use a calculator to double check a graph if you run into something weird. I think in the homework I give you a lot of the pictures so you don't have to guess what it looks like. We are trying to express the area of the rectangle as a function of the x-coordinate of its bottom left-hand corner. Okay, so we put its bottom left-hand corner somewhere. Here I'm just going to draw one to get us started. And the top left-hand corner will hit the curve y equals the square root of x. And then we'll head straight across until we hit the right-hand side at x equals 9. And there's our rectangle. So if we were doing the calculus step here and talking about trying to get the biggest rectangle, basically what happens is we have kind of a balancing out happening. We get to determine what this x-coordinate right here is. So we could make this x-coordinate really, really small, and what would happen is our rectangle would get fairly wide, but it would be very, very short. We could also make our x closer to 9, and that would make the bottom of our rectangle very skinny, but the height of the rectangle would be taller. So somewhere in there should be some best possible value of x, best meaning it gives us the biggest area. So you're not responsible for the biggest part, but I do want you to be able to set up the area formula. And again, we can talk about the domain of this thing. So we're looking for area A as a function of x. And again, if you can get the formula for this easily and you don't need to write any steps, then don't write steps. But here I'm looking at a rectangle, so my step to get me started, if I'm a little stuck here, is to say, okay, to get the area of a rectangle, I need a length times a width. And I need to get both of those things in terms of my variable x. So we're looking for, we can call whichever the length and the width. I'll call this the length and this the width, but it's entirely up to you. So to get the, yawning again, I shouldn't make these at night. To get the length of the rectangle, I want the distance between the left-hand side at x and the right-hand side at 9. So I'm looking for this horizontal distance. It's like looking for a run, right? Distance between two x coordinates. So that length is going to be 9 minus x. Whatever x is, we want whatever is left over to get from there to 9. So if x is 1, the length of the rectangle is 8. If x is 2, the length of the rectangle will be 7, and so on. The width of this rectangle, okay, so it's important to realize for starters that we don't need to throw in another variable for this. Once I've chosen the x-coordinate of this corner, I can calculate the length, and the height is determined for me by the function y equals the square root of x. So I don't get to just say, okay, well, the length is going to be 7 and the height is going to be 4. As soon as I figure out what the length is, that's fixing a specific x value, and that's determining the height of the rectangle without leaving me any options. So sometimes people actually get a little stumped on this, but it's less tricky than it might seem. We have an equation for this function. The height of this rectangle is basically the y part of the equation, and the equation tells us that y equals the square root of x. So if I put the left-hand corner at x equals 4, the height of my rectangle will be the square root of 4, which is 2. If I put the left-hand side of my rectangle at x equals 3, the height of my rectangle will be the square root of 3. So in general, whatever the x-coordinate on my left-hand side is, the height of the rectangle is going to be the square root of x. And I don't really care if you rewrite these things or not. I feel like that's in sort of a funny order, so I'm going to rearrange a little bit. You could also distribute. I'm not picky about simplifying these things very much. If there's some really easy stuff to do, please do it. But things like should you distribute or not, I don't really care. The other part of this one is determining domain again. So remember, this is all about looking for extremes. I'm not looking for you to make the best choice for what x should be. I'm just looking for you to tell me what all of the possible choices for x are. So minimum possible x value in this situation, I would say, is 0 again, actually. If x equals 0, the base of your rectangle, the length I called it, is 9, but the height is 0. So it's a terrible choice if you want to actually get a rectangle, but it does have some practical meaning in this problem. I can actually point out what that means in this picture. The largest possible value of x I could choose is 9. The right-hand side of this rectangle is supposed to be at x equals 9, so putting the left-hand side also at x equals 9 is definitely my extreme. If I move past that, it's not the left-hand side anymore. So 9, again, this doesn't actually give us a rectangle. If I put x at 9, the length of my rectangle, the base here, is 0. And the height is 3, so it's actually just a little vertical line segment. If you're really bothered by the fact that it's not a rectangle, once again, you could leave off the equal to, but I personally think they're fine there. They don't give us a rectangle, but they do give us the extreme. All right, that's it for this one. Thanks for watching.